Well, hello and welcome again to the Random Bros. If you remember, this is where we left the CNC machine. Since we had to move from the shop we used to be because of a certain virus, we just keep working in our place with whatever tools we could lay hands on. So, X and Y axes were ready. Then we started building the base of the machine using square tubes. Next, we had to make the mounts for the motors. Z and X axis ball screws move using a belt system with Excel pulleys, and Y axis is directly mounted to the ball screw. What you see here is just a locating pin to hold it in place in order to adjust and weld it. Next, we had to learn how to cut some keyways on the lathe to make the coupler fit. And then Y-axis was done. With the table ready, we started working on the Z-axis column. We bought two U-shaped steel beams. After cleaning them up, we faced the two sides and used some pre-calibrated square rods to mount the linear bearings on. Having access to an actual workshop like the previous part was really helpful, but we had to keep it up, so we had to figure ways around it. Now for the spindle mount, we again took a U-beam, smaller this time, and drill it to give access to the spindle. We also added some reinforcements at places that the stress analysis indicated as weak spots. After that, we had to assemble the electronics. The electronics part has to be a video on its own because the information is too much. What you see here is the first cut we tried on this machine, and it's on real time. The machine performed as expected, but we still have to learn a lot of things on the CAM software in order to push it to its limits. As you can see, the machine is nearly finished. All that's missing is to add the cooling system, add some cover to the rails in order to protect them, and build some kind of a system around the table just in case something comes flying out. Now it's time to explain how the Z-axis works. So we just bought two U-shaped steels, as you saw in the build video, and we bolted them together. Then the whole compartment slides in and is bolted to the rest of the machine. We have 4 bolts here, 4 to the other sides, and we have another 6 bolts here. Then the whole Z columns is mounted on the table, and the table is mounted on the ground, so it's pretty stable. Most of you have probably seen it already. One of the biggest changes need to be done on this machine is to change all the 3D printed parts on it. The base for the Z-axis motor is 3D printed, the pulleys are 3D printed, and the same stands for the X-axis. So we have to buy actual aluminum pulleys to replace those plastic ones. One other thing we have to do on this machine in order to be ready for work is to fill it. For now, we have filled everything with sand, but I think it would probably be better to fill it with something else, like resin, but it's way expensive for us to do this right now. If you have any other ideas, leave us a comment below. The other thing we need to change on this machine is the gearing system between the spindle and the motor. The spindle is a Sherline product and it's really good. I really liked it so far. It's easy to mount and for now it holds pretty well. But the motor is a 2.2 kilowatt, 3000 RPM, and I think it's quite slow for the application we needed. The gearing ratio now is 2:1, so we have around 6000 RPM on the spindle, which is not enough for aluminum. I think we need to increase everything up. So, just to get something clear, this machine has a 1 meter ball screw on this side, 1 meter on this side, and 500 millimeters on this side. So the actual travels of the machine are 700 millimeters on this, 500 millimeters on this, and 300 on this. One other thing that troubles me on this machine is the design of the Z-axis carrier. I think it should have been way stronger than this one, even though I haven't seen any vibrations for now. One thing that made a hell of a difference on this machine is adding the compressed air tanks. They lift all the way so the motor moves freely. As far as the electronics go, we have 3 NEMA 34 stepper drivers with encoder and a 2.2 kilowatt motor that drives the spindle. The software we use in order to control the machine is Mach 3 with a skin. We can leave you a link to the skin below. We didn't design it ourselves. We just added the controller just for fun because we always wanted to do that. Just before I go, I would like to thank everyone for the patience you did in order for this project to be completed. I am sorry, but the whole COVID situation drew everything back. Thanks a lot for watching, and if you like this video, please feel free to share it, subscribe, or anything you want to do. As you probably see, we are making kind of a big project in this channel and we have less than 3,000 subscribers and we just need some push to keep on. Thanks a lot for watching and have a nice day from the Random Bros.